Hey everyone, so we're going to be solving equations with what we call like terms. And what a like term is basically is it's just a term with the same variable. In this case, my variable is x and x. So negative 19x and positive 9x are going to be like terms. And then negative 20 is going to be kind of by itself here because it doesn't have an x attached to it. So if I have negative 19x's and I add 9x's to it, well, negative 19 plus 9 is just negative 10. So I have negative 10x after I combine these like terms. And then that's equal to, and negative 20 just kind of sits here because there are no like terms to combine it with. And so that leaves me with an equation negative 10x equals negative 20. Now again, I am solving for x here. So I have to undo the operation that's happening to x to get x by itself. And that operation is negative 10 times x. So how do I get x by itself if I multiply it by negative 10? Well, to undo it, you divide it by the same number, negative 10. And then I have to divide both sides by the same number, otherwise my equation is unequal. And so then that means that the negative 10s will cancel, and negative 20 divided by negative 10 is just a negative divided by negative, positive 2. And so that means x is equal to negative 2 is my answer. All right, let's look at one where all the like terms are not right next to each other. And here we have a little bit more complicated of an equation, but it's really no different. So what I like to do is I like to split it up by sides. So first and foremost, I'm just going to think about the left side as a whole and then the right side. And on the left side, I notice 13 and negative 7p. These are not like terms. If there was a p here, then these would be like terms and I would be able to simplify it to a 6p. But it's not a like term. So I can't have that p there. Otherwise, I'd be altering the equation. On the right side of the equation, I notice there's only one variable with a p, but I do notice that there are two variables that are just solely numbers. So what I can do is I can combine these like terms. So I have negative 6 plus 6, they're both like terms, and negative 6 plus 6 is 0. And then I'm left with negative 6p on this side. And on the left side, 13 minus 7p stays the same. And I can simplify this down a little bit further because 0 minus anything is just that something. So I'm going to rewrite this as 13 minus 7p equals negative 6p. And now I don't have any like terms on the same side of the equation, but I do notice here, and let's switch over to blue, that negative 7p and negative 6p are in fact like terms because they have the same variable. They both are p's. So now I need to figure out how do I get this negative 7p over to combine with my negative 6p? Well, this is where we work on solving equations and the technique that we used last time. And so if I want to get this negative 7p over here, how do I get rid of negative 7p? Well, I just simply add 7p to make it go to 0. And then if I add 7p to this side, I also have to add 7p to the right side to keep the equations balanced. And that means that when my negative 7p and positive 7p go to 0, I'm left with just 13 on this side. Right? This guy is still here. Don't forget about him. And then I have negative 6p plus 7p. So if I have negative 6p's and I add 7p's to it, that means I'm going to be left with one positive p left over. So I could write this as 1p, but it's also the same thing just to write it as p. And look at that. I noticed that 13 equals p just happens to be here. If there was a number like 3 or something like that left over in front, well, all we'd have to do is then divide by 3 to solve for p. But in this case, it's just 1p, so I know what p is now. It's equal to just 13. All right, I hope this helps, and thanks for watching.